Um, okay, good morning. So let us start lesson today. I will not restrict myself to exactly the book. So let us go a little bit beyond what is written in the book because it doesn't matter now that there is no example of that. Okay, so let us talk about first order. So I think the most important first order differential equations are actually very broad. Yes. So if you have a function, for example, first order means that you have the first derivative involved. So assume that you can solve that differential equation and write y prime on the left and f of x and y on the right. So this is a generic form of the first order differential equation. Okay, so here what I have written, of course, this is probably, you haven't seen this situation. This means that you have an expression in terms of x and y. Yes. So unfortunately, you cannot say that I can just integrate and solve it because the unknown function also appears on the right-hand side. Yes. So that's the problem. So this is why mathematicians actually categorize these first-order differential equations to simple cases and probably important from application point of view. Yes. And one of the ones that we want to talk about today is first-order linear differential equations. Okay, so I will emphasize on the word linear later, but let me just introduce you what I mean by a first order linear differential equation. I will talk about the linearity part later. It's a very important property, of course. But any differential equation of this form, if y prime plus a function of x only, yes, multiplied by y equals to a function of x only. So this is called a first order linear differential equation. Okay, so when we mean linear, it means that this function that you see is only a function of x, and this function that you see is a function of x only. For example, I can in principle write y prime plus, I don't know, I can write e to power y times y is equal to x squared. This is first order, but it is not linear. Because if you see what is multiplied by y is not a function of x, is a function of y. So this is not linear. So this is not that easy to talk about. Okay, or for example, you might have y prime plus sine of x times sine of y times y is equal to x to the power of 2 plus 3. This is again a first order differential equation, but not linear, because you see the function which is being multiplied by y is a combination of functions of x and y. We need to have it as a function of y. Yeah? As a function of x. So if you have a differential equation having this format, this is called first order. Of course, it is clear. The highest order derivative is 1. And it is called linear. Okay? So we want to talk a little bit. Of course, in your book, they have talked about a very, very simple and special case of this, but I don't think that is hard to understand it in a little bit more general context. Yes? Okay, but let me start with a very, very simple one. Okay? So let me, instead of taking them as a function of x, let me take them as a constant function of x. For example, let me just give you an example. Y prime plus 1 times y is equal to 2. This is a differential equation, yes? So if I ask you what is playing the role of p of x, you would say p of x in this equation is a constant function. Don't get confused. Constants are also constant functions. So is 2 a function of x? Yes, it is a constant function of x. That's p of x. Oh, sorry, this is 1. Let me bring my own. So that is 1 and qx is 2. Okay, do you have any idea how to solve this? This is a very, very simple differential equation. Even this simple one might be not easy to guess, yes, how to solve it. So let me start from here. So y prime plus y equals to 2. Here you have p of x equals to 1 and q of x equals to 2. Yes? So do you have any idea? You want a function so that when you differentiate it once and add it to itself, it becomes 2. You might start thinking about an educated guesswork again as before. That's one way. We will learn about that again later. That's good skill to learn. But let us think a little bit differently. I want to give you a little bit of hint. I multiply both sides by e to power x. Okay? But let us see why this happens. I multiply both sides by e to power x. First of all, I'm on the safe side because e to power x never is 0. So I'm just multiplying both sides by a non-zero number, which is always acceptable. But do you see what is the benefit of doing that? Look at the left-hand side. What is happening to the left-hand side? Left-hand side can be written in a slightly different way now. People at home also. You see? Do you see that this combination is familiar? No, that's a product rule. Yes, that's the product rule of derivative. And the reason that's confusing because the derivative of e to power x is e to power x itself. So what I'm saying is that the left-hand side can be written in this form. Okay, and the right-hand side is just 2 e to the power of x. Let us double check why this is true. Because you see that's a product of two functions. E to power x is a function of x, and y is definitely a function of x because we are looking for a function of x in the differential equation. So that's a product of two functions of x, and I want to differentiate it. According to the product rule, it becomes the derivative of the first one, which is e to power x, multiplied by the second one itself, which becomes y. It gives me the second term. And then plus the first one multiplied by the derivative of the second. So do you see that? How should I proceed now? It is simple now.
We take a primitive function.
Yes, because I don't know this guy, but I know something about it. I know its derivative, whatever it is this function. Yes, so it means that e to power x y is equal to the primitive function for this. If you don't mind, I don't know why they have done this in this Swedish system. I do remember I used PRM, just something like I just invented myself for primitive function, but let us replace it by integral. Okay, so for example, if I want to ask you find the primitive function for f, in higher actually level, they denote it by this symbol, f of x, d of x. So whenever you see this symbol without these limits, it means that you are interested in all primitive functions of this function f of x. Yes? So if you don't mind, let us switch to this notation finally. I don't think that's a big problem. So for example, instead of asking you what is a primitive function for x squared, I can ask you to calculate this integral. Yes? So this dx is just nothing for you. It just means that a primitive function for x squared. Yes, what is the answer now? It becomes x to the power of 3 divided by 3 as the rules that we know, plus a constant. Yes? Are you comfortable with this symbol? Yes? So if instead of write a primitive function for x squared, I just ask you to calculate this indefinite integral, if you want to call it. Yes? For the case that we studied, we have a lower limit and upper limit. We call it definite integrals or simply integrals. Okay? So let us just use this symbol. Okay, so here, if I ask you this, as you know, I want to find a primitive function for this. So instead of writing primitive function of this, if you don't mind, let me just use this symbol that we have. This means primitive function of that. And this dx here emphasizes that x is your variable. That's it. Yes, is that understandable? Okay, but can I calculate the right-hand side? Yeah, it is very simple now. What can I calculate for the right-hand side? What is a primitive function for this? Do you know?
2ex plus a constant.
Plus a constant. But what I'm looking for, do you know? When I want to solve a differential equation, I am looking for finding y in terms of x if possible. So what I have to do, I have to divide everything by e to power x. Because I'm looking for y. Yes, so it becomes y equals to, when I divide by e to power x, the first e to the power of x is gone, c divided by e to power x. But I myself prefer to write it in a little bit different way. I would write c first, I bring it up, it becomes e to power minus x plus 2. By the way, can I call this the general solution of my differential equation? Is this the general solution of this differential equation?
Yes.
Yes. If you want, we can check that this is indeed the solution, but because it contains one free parameter, and my differential equation is of order 1, so it means that that's the general solution of my differential equation. So if you don't believe, we can check it here. Checking the solution. So how should I check the solution? How should I check the solution? I need to put it here. So the left-hand side is y prime plus y. But what is the derivative of this guy? The derivative of this one is minus ce to the power of minus x. Derivative of 2 is 0 plus y itself. Yes? And then if you see this one and that one, regardless of the value of c, it's gone. And what is left for me is just 2, and that's exactly the right-hand side. So you don't need to check it, because what we have done is completely correct. But this is the idea. This function that I multiplied here, what happens for this? When I multiplied both sides here, what I got a complete derivative. The derivative of a package, yes, so that I was able to take integral, to take primitive function from both sides and to get rid of this prime and make y here so that I can divide by this expression to find my y. This expression that I am multiplying here, it's called in this context, it's called integrating factor. So a factor that I multiply both sides of my equation by that factor so that it turns the left-hand side into a complete derivative, the derivative of an expression. Okay, but it was not hard to guess this integrating factor here, so it was easy, more or less easy. But the question is that, can I do this in general? Can I do it for just the differential equation in this form, regardless of the functions of p of x and k of x that I choose? Can I use the same trick again here? Of course, it is not trivial what is playing the role of e to the power of x in general, yes? So my goal is to multiply this expression by an integrating factor. Usually in differential equations, it's called mu of x. I want to multiply this expression by mu of x. Okay, so that I want to find this mu of x if possible. We don't know. We want to see if it is possible in general or not. That I multiply this by that expression and it becomes equal to mu of x, y totally prime. I'm asking this question of myself. If it is possible to find such a function, then I can follow the same strategy to solve the problem. Yes? So let me explain again. It's not clear that I can answer this question, yes? I'm asking myself, is it possible that in the general case, I can find a function which will play the role similar to e to power x here? So do you remember, when I multiplied this by e to power x, I was able to write it as the derivative of e to the power x that I multiplied by y totally prime. So that's the question. Can I find a function like this so that when I multiply it on the left-hand side, it becomes equal to this times y totally prime? Because if I can find that, then I am done. It doesn't matter what I have here. Then I will have mu of x times y equals to something. Then I divide by mu of x and I will find my y. But of course, and then we are lucky because the answer to this question is yes. We can always find that. Let us check and find that. Okay, so if it is going to be possible to find such a function, let us multiply to see if I can find the formula for mu of x. I multiply it inside. And on the right-hand side, I expand it. What is the derivative here? This is the derivative of a product, so it becomes the derivative of mu times y plus mu of x times the derivative of y. Don't forget the logic. The logic is to find mu of x if possible. Yes? And now what is happening? You see here, mu of x times y prime appears on the left and on the right, so they can be cancelled from each other, from both sides. And then what happens here, so let me just write it here. So, by the way, I divide by y, it becomes mu of x, p of x is equal to mu prime of x. Yes, first I got rid of these terms, and then I divide by y, assuming that I am working on an interval that y is not equal to 0. This is, of course, essential. And then let me divide by mu of x again. So it becomes mu prime of x, mu of x. Don't get lost. My goal is to find mu of x, but do you know how can I find mu of x now? Is mu prime of x divided by mu of x familiar for you? So let me open up a space here because I want to check that one. This combination should be very familiar for your eyes. The derivative of something in the numerator and the function itself in the denominator. What is that? Exactly, thank you. So that's the derivative of L. Okay, now I'm asking you this question. Here, this is not known to me yet, yes, because I don't know mu of x yet. But I know something. I know the derivative of this combination is equal to p of x. And don't get confused. P of x is given to me because they give me an equation and then ask me to solve it. So it means that they give me p of x. Okay, so p of x is something known. And then I want to find mu of x. So what is your suggestion now? The derivative of this is this one. If I ask you what is this blue one, you would say what is the blue one is the primitive function of this one. Is that understandable? Because the derivative of this blue one is equal to that. It means that ln of mu of x is the primitive function for p of x. But we learned the notation today, so let me write it as in this form. Primitive function of x. Yes? But what I'm looking for? I'm looking for mu of x. Okay, can you tell me what is mu of x? E to the power of this integral, yes? It seems complicated, but not hard, yes? Yes, so you have this e to a primitive function is mu of x. So we got the formula. So we succeeded actually to find a formula, a generic formula for the integrating factor for first order linear differential equations in general. So that's a great success actually. Yes? Okay, so, and now, so it means that if I ask you to solve this differential equation in general, we find a method of solving, not just guessing, you know? So do you remember the reason that it becomes e to power of x? Why do you think that this, in this case, the integrating factor was this one? Assume that I want to just calculate the integrating factor for this case. So according to the formula we got, it is e to the power of integral. So what is p of x in this problem? 1. So instead of p of x, I have to put 1 d of x. But what is the meaning of this symbol? It is asking you the primitive function for x, for 1, which is x. So it becomes e to power x. And this is the reason that I multiply it by e to power x. But the problem is that you might say that there is a constant here. Of course, there is not one integrating factor. You get infinitely many integrating factors, so that, for example, if I write this one, or if I write this one, that's also correct. This will also play the integrating factor, but one of them is enough. I want to solve my equation. I don't care about how many integrating factors are there, so let us choose the simplest one. So you see that this one was a little bit of guesswork here, but now you see that I have a formula, so that I can always use the formula to find the integrating factor, but the method you need to learn. So if I want to summarize, what we learned here is this. Actually, we can find a general solution if you want to, but I want you to do this process one by one so that you can learn that. So assume that I give you this differential equation. By the way, it's important to emphasize that this expression is 1. So let me write a 1 here, because sometimes it is not 1. If you want to follow this step, it's like PQ formula. You remember you need to divide by something to make it 1. So you have to make it 1 so that this method will work. Okay? Okay, so if you have this, the first step is to find what? To find the integrating factor using this formula. So e to the power of integral p of x dx. And then 2, so you multiply both sides by mu of x. Number 3, the left-hand side becomes mu of x y totally prime. It's always the case. You can always check if you want to, but this is always happening. So how should I solve that one? Then this becomes mu of x y totally prime is equal to mu of x times q of x. Agreed? If you multiply both sides by mu of x, of course, the right-hand side, it is clear, it becomes mu of x times q of x, but the left-hand side, because what I told you, it becomes this one. So then you can say that mu of x y is integral of mu of x, q of x, d of x. And then plus a c. Let me just emphasize putting c here. And then if you want to find y, you divide by mu of x. Something like that. Of course, there are some minor flaws here that I don't want to confuse you, so I put C here. So you can memorize this it's like a ABC formula. So if I give you a quadratic equation, you can plug this in that equation, the formula, and then you find the answers. Here, that's the formula. That's the generic formula. But if someone asks you what is mu of x, it's a more complicated formula. It's integral inside an integral, yes? So mu of x itself is this expression. Okay, so let's start solving some problems together. In your book, they only consider the case that p of x is a number and q of x is a number. So the one that I started with is at the level of the book, but not the general case. But you see that the general case is also some doable and it's not hard. Okay, so let me, the only problem that I want you to understand is that at the level of your lesson, calculating this integral, this primitive function becomes hard for you most of the time, because the level of the knowledge about how to determine the definite, indefinite integrals is limited here. So the only downside about this method, even though it's completely generic, is that calculating these primitive functions sometimes becomes very hard, and sometimes, of course, impossible. Okay, but so let me just give you a very simple example first. So we want to solve this equation. This differential equation, x y prime plus y. Of course, this is very simple. I don't know why they mentioned this example. But if I increase the level, it suddenly becomes too hard. Yeah. So yeah, let me start with a little bit non-trivial. By the way, let us start with this example. This is equal to x. This is, first of all, it is not in the standard form of a linear differential equation, yes, because the linear differential equation y prime, the coefficient of y prime should be 1. Yes, assume that x is positive, not 0. Okay. By the way, this is not hard at all. The reason that I didn't like this example, because probably you really don't need to go into this mess, yes, because you can solve it easily. Can you see that? What is the left-hand side immediately? I don't know why the book has solved it in this way, but what is the left-hand side? This, yes?
Product.
Yeah, that's the product rule. That is x, y prime. Yeah, so if I myself want to solve it, I will never go through this long step, because the left-hand side is just nothing except this. The derivative of the first one is 1 multiplied by y, it becomes this. And this one multiplied by the derivative of that one. So that's correct. So if I want to solve it, so it is much simple. You really don't need to know anything about those things to be able to solve that. So then you take a primitive function, so xy is the integral of x dx, and then you write xy, but the integral of x dx is x to the 2 divided by 2 plus a constant, and then you are looking for y, you divide by x, it becomes x over 2 plus c over x, so that is your solution. Yes, so you really didn't know this method, but let us pretend that this method is not available. Let us pretend that we want to solve it in that way. But if you want to solve it in that way, it is crucial to make this y prime, the coefficient of y prime, to be 1, if it's important. So here, this means that if I want to follow that process, the first step that I have to do is to divide by x. So this becomes y prime 1 over xy is equal to 1. Yes? This is crucial. Now I go first to step number 1. Step number 1, I have to calculate this. So tell me, what is p of x then? So p of x is nothing except 1 over x, and q of x is equal to 1. Yes? So then mu of x is e to the power of integral 1 over x dx. Okay, now can you tell me what is the integral? What is a primitive function for 1 over x?
ln
Ln of x. Yeah, so this becomes e to the power of ln of x. But it is also a famous combination. What is e to the power of ln of x? X itself. So here, the integrating factor is x. And then you are producing actually the same thing. So do you remember, I am supposed to multiply both sides by x. You see? So this becomes x. I multiply it here, xy prime plus y is equal to x. And then this becomes exactly mu of xy prime. Mu of x is x, so it becomes xy prime is equal to x. And the rest of the story is exactly the same. So it was not a very good example, even though you can solve it using that method. Let me see if I can find a better example. Of course, there are better examples, but then suddenly becomes harder. I think I can also teach that part. It's not hard. But let me, before going to that, let me see that if we can solve a different problem. I need to check it myself first. Yes, for example, let us consider this. So let me clean this and solve some of these examples. Here, I hope that you can solve this. If I can see it, I think you can solve this one. So let me write it in Leibniz notation this time to get used to this way of thinking. So this one, let me write x here, and then minus 2y this time is equal to x to the power of 3. Okay, so this is a little bit non-trivial example, even though it's not hard, but non-trivial. Okay, so first of all, do you agree that this is a first-order differential equation linear? Yes, but this coefficient is not 1. If I want to use that method, I have to divide 1. So I'm assuming that x is not 0, so I can divide simply by x. So the first step is to divide by x. Then it becomes minus 2 over x, y. On the right-hand side, I will have x squared. Yes, this is the first step. The second step, I have to calculate my integrating factor. So I should have it in my memory, okay? So e to the power of integral of p of x, d of x. It's better to write p of x and q of x in front. So what is p of x? Can you tell me?
minus 2.
Minus 2 over x. And what is q of x? It's just x squared. So the integral e to the power of, so this I would write e to the power of integral of minus 2 over x dx. I am looking for a primitive function for this one, but minus 2 is a constant, so I don't care about that multiplicative constant. I concentrate on finding a primitive function for this. So do you remember I told you that a primitive function of a number multiplied a function, you can just take it out. And then what is the answer here? It's e to the power of minus 2. The integral of this is as before ln of x. Yes? But how can I simplify this? Yes?
E to the power of minus 2 multiplied by e to the power of...
No. You're close. Yes?
It becomes e to the power of minus 2 times x. Right.
So I don't know, how do you think? You can solve it in different ways. You can imagine it as e to the power of ln of x to the power of minus 2 if you mean this, yes? Because then it becomes x to power minus 2. Or you can, of course, you can take this number and put it on top of x. So it becomes, this is better probably. And then e to the power of ln of something, it is x to the power of that minus 2, yes? And then x to the power minus 2 has a better name. It's 1 over x squared. Agree? So what does it mean now? It means that my integrating factor was not a trivial one here. It's 1 over x squared. So I have to multiply both sides of which equation? Not the original one, the one that have the coefficient 1 in front. I have to multiply both sides of this equation by 1 over x squared. If I multiply that, let me write it in the normal notation now. So it becomes 1 over x squared. This becomes y prime. This becomes minus 2 over x cubed y. And then I multiply this by 1 over x squared. It becomes 1. Yes? So here it was not that easy to guess that integrating factor is this expression. But it might be a little bit strange because you say that this is supposed to be a product rule, but why there is a negative sign? But don't worry about that. This is definitely this one. So let me write, and then if you want, we can confirm that. So I would definitely, when you do everything right, the left-hand side, after being multiplied, it becomes the derivative of your integrating factor, which is 1 over x squared, multiplied by y, the derivative is equal to 1. If you don't believe that, we can check it again. But if you have done everything right, don't doubt about it, it will work. So let us go to scratch paper here. And I want to confirm that if I use the product rule, this will go back to this expression. Okay, and that shouldn't be hard. I will take the first one multiplied by the derivative of the second one, which by no surprise, it gives me the first term, so that's easy. But plus the derivative of the first one multiplied by the second one, yes? So I didn't write the first one because it was trivial. The first one multiplied by the derivative of the second one plus the derivative of the second one multiplied, so the derivative of the first one multiplied by the second one itself. But if I want to take the derivative of that, I bring it up. It's easier to avoid the quotient rule. And then minus 2 goes down, and x becomes to the power of minus 3y. But no, you agree that I can write it as minus 2 over x cubed y. And that's exactly what you see here. Yes? So no doubt, if you have done everything correctly, don't doubt about this part, even though it seems a little bit strange, because it might be saying that, okay, how this is going to be a product rule, because in the product rule I have the sign, but this minus sign is coming from the derivative of that. Okay, so if you do everything right, then definitely the left-hand side is correct. And then now that you also confirm that, which you really don't need, you can now calculate y, yes? So how can I calculate y now? I would say that this is something whose derivative is 1. So let me write everything. So I would write that 1 over x squared y is the integral of 1 dx. And then this becomes 1 over x squared. I want to find all primitive functions of 1. It is clear. It is x plus c. But now I am going to find y, so I multiply by x squared. So it becomes x cubed plus cx squared. So that is the general solution of this differential equation. And it was not easy to guess, even though that's not a complicated function, but it was not easy to guess that this will give rise to this one. Okay, so let me give you another example. So y prime plus 3y is equal to e to the power of 4x. Let me write 2 here as well. This is at the level of Math 5, even though they have talked a completely different method to solve that. I will come back to it. That's also an important method to learn. That's called the method of undetermined coefficients. But now we in principle, there is nothing mysterious for us here. We can solve all first order linear differential equations. Yes, this is the method that I brought here is completely generic. So here, but you might see some of these questions in your Math 5 book. They don't mean to solve it in that way. I will come back to that probably, hopefully we have time later. But let me just solve it using this method. Okay, so you see that this coefficient is 1, so I can immediately start. So what is P of x here in this problem? So P of x is actually equals to the constant function 3, and then mu of x is the formula e to the power of integral P of x dx. So then it becomes e to the power of integral 3 dx, and then if I ask you what is the primitive function of 3, then you can immediately tell me that it is 3x. And so that is my integrating factor. What I have to do now, I have to multiply both sides by this equation, by this integrating factor. So it becomes e to the power of 3x multiplied by y prime plus 3e to the power of 3x y. On the right-hand side, I have to write e to the power of 3x multiplied by e to the power of 4x. Okay, but can you tell me what should I write instead of this? You don't need to doubt. It is always the derivative of your integrating factor multiplied by y. Your integrating factor is e to the power of 3x multiplied by y. If you want, of course, you can check all the time. If you haven't done something wrong up to this point, it will not be wrong here as well. So if I take consideration that the derivative of the first one is 3e to power 3x multiplied by the second one, plus the first one multiplied by the derivative of the second. Yes?
Shouldn't there be a 2 on the right side?
I should what?
A 2.
There is a 2. Thank you. Thank you. Yes, thank you. And then, of course, I can combine them here. Do you agree? So it becomes e to the power of 7x. Now what I have to do, I have to calculate e to the power of 3xy. If I integrate this, so let me write everything in detail. 2e to the power of 7x dx. Okay? And then if I calculate this integral, or the primitive function of this, I hope that you agree with me. It is 2 over 7 e to the power of 7x, and then plus a constant. Agree? That is my goal. And then I'm looking for y, so I divide everything by e to the power of 3x, so it becomes 2 over 7 e to the power of 4x, and then the c e to the power of minus 3x. I prefer to bring it up to make it negative. Of course, you can keep it in the denominator. So that is the general solution for this linear differential equation. Yes? Okay, now, even though completely it is different from the book, let me just teach you this one as well with some motivation. I told you that the only hard part in solving this is solving integrals. So let us teach you some important trick which you will learn in the university later, and that's called integration by parts. So let me motivate you a little bit by one example, okay? Let us motivate you exactly in this context. So assume that I give you this equation, and I want you to solve that. So let me think about it. Yes, I even want to make it very simple. Okay. So remember these examples. Might be we come to these things back on Thursday to see that this is exactly at the level of Math 5 again. They are asking you to solve this, but not by this method. By a method is called the method of undetermined coefficients. And then you will see why that method is sometimes superior to this method, to this generic method. Let us pretend nothing is wrong. Let us start solving this differential equation using the method that I've developed here. So what should I do first? I need to see what is p of x. This equation is actually very simple. So it is 1, and then the integrating factor here is e to the power of integral of px dx. But then what happens? It becomes integral of 1 dx, but everyone knows that this is just simply e to the power of x. And then I multiplied both sides by e to power x. And then the left-hand side automatically becomes this, no doubt about it. And then I take the integral from both sides. This means that this is my primitive function. Yes? So surprisingly, if I ask you, can you give me a primitive function of this function, what is your answer? You see, the problem is that you agree that this is very, very simple differential equation, yes, comparatively. But I come to a problem. And so here, this is a primitive function for this. Now I'm asking you, can you guess a primitive function for x e to power x? Do you remember I told you about this? So I told you this rule. Do you remember? Primitive function of f plus or minus g is equal to the primitive function of what? F plus or minus primitive function of g, yes? And then let me write it in non-new language. So I would write integral of f of x plus g of x, d of x. This means the primitive function for this is equal to the primitive function of the first one plus or minus the primitive of the second one. Do you remember? And if you remember, if you go back to what the rule is, I emphasize that don't get confused. Primitive function of the product is not equal to the primitive function of f multiplied by primitive function of g, yes? And I crossed it over. Okay, so if I can go back here, my goal is to find a primitive function for this combination. If I ask you a primitive function of x, you know. It's x over 2, x to the 2 divided by 2. If I ask you a primitive function of this, you know. But unfortunately, they are being multiplied. If I ask you what's the primitive function for the sum, you know. What is the difference, you know. But this is a product. And I have emphasized that there is not a formula for that. There is actually a formula. It's not a very nice formula like this, but you can cook up something for this one, which becomes useful in some of the calculations like that. And this is the method of integration by parts. So let me just give you the title here for you. And I want to teach a little bit. In some Math 5 books, I think in Math 5000, we had it when I came here in the first year, but I don't know. So it is not completely beyond the level of math knowledge that you have. So now you understand what's the point. The point is that forget about everything momentarily. Try to concentrate. If there is any systematic way to calculate a primitive function for the product of two functions for which we know a primitive function for, yes? So let us see if it's possible. So my goal is actually, I want to find this. So let me write method of integration by parts. Integration by parts. This is the name. So that's a deviation a little bit to the topic of differential equations, but the motivation that now we are interested in because we want to solve the differential equation. So I try to cook up a motive for you. The formula is a little bit complicated. So if I give you f of x, g of x prime, the derivative of that, so then you would say that, let me write it like this. So let me assume that primitive function of a function f is the capital F, and then primitive function for little g is g. Okay, so if I ask you, do you know a primitive function for little f? Assume that you say yes. Do you know a primitive function for little g? Assume that you can say yes. For example, this is your f, this is your g. Okay, and then my goal is to find a primitive function for fg. Or I want to write something in front of that, okay? I want to find a relation for the primitive function of the product of these two functions. Okay, in the new language, we want to calculate a primitive. So let me ask you this. So instead of this question mark, let me call it. So how should I say it that you can understand it here? So, okay, let me write the formula for you here so that we can prove it. So my claim is that primitive function for fg is equal to. This is a little bit different from what I have in my memory. I want to write it in a way that you understand it. So this becomes equal to the capital F of x, g of x, minus the primitive function. Let me see the formula. So it is the primitive function for, it's complicated a little bit in this symbol. I will change the notation. So if I write, it's capital F x and then g prime of x. So first of all, let me see what I have calculated before is correct. If capital F times g minus, yes, of course you will never see it in this form in the university text. This is why I don't have it in my memory. But actually this is a very nice way to understand that, because when we were talking about primitive functions, we talked about primitive function of the sum, we talked about the primitive function of the difference. But this is a little bit natural question. Do we have any formula for the primitive function of the product? It is not that simple as before. So for the primitive function of f plus g, I just wrote a primitive function for f plus a primitive function for g. But now here, this becomes this expression. So it's complicated, yes? But if I want to prove it, can you tell me how should I prove that? If I want to prove that this relation is correct.
We take the derivative.
Of what?
The right-hand
side, and show that what happens?
It becomes equal to f times
g. Thank you very much. So this is the claim. The claim is that primitive function of this is this one. This is proposed to you, and then you're supposed to show that it's truth, yes? So what you do, as you said, I will take the right-hand side derivative, and I tell myself, is it clear that this becomes fg itself? If I can show this, I am done, yes? Because I want to show that this right-hand side is a primitive function for fg. So it means that I have to take the derivative of that and show that this is correct. But now, can you help me to take the derivative of the right-hand side? Derivative of the right-hand side is two parts. So let me just write it one by one. It's a little bit confusing of notations. Yes, and then first of all, do you agree what I have written here is the derivative of the right-hand side? On the right-hand side, I have two terms subtracted, and I want to differentiate it. So I have to differentiate the first term minus I have to differentiate the second term. But let me ask you, what can you write for this one? This one is a product rule, yes? So it becomes the capital F prime multiplied by g of x plus capital F multiplied by g prime of x. Do you agree? Yes? This is the derivative of this one. But can you tell me what is the derivative of this?
Capital F of x.
Exactly, because this is the primitive function of this and you are differentiating it. So it means that this becomes minus this expression. Yes, it was actually, it seems complicated, but the proof is very simple actually. Is that understandable? And now what you see, do you see that this one and that one are gone? But what can I write instead of capital F prime? Little f, because f is a primitive function for little f. So this is just nothing except f of x, g of x. So I hope that at least you don't know how to use it yet, but at least at the level of this notation, you agree with me that this is a true equality. Okay, now let me write it in a more familiar language for myself. Okay, so when I want to write, instead of primitive, I use this symbol of integral. So I would write it in this way. Integral of a product of two functions is equal to f of x. So let me write it f of x multiplied by g of x minus, instead of primitive, I write integral again, capital F of x, g prime of x, d of x, where capital F of x is a primitive function of f of x. So this is the formula of integration by parts. Still, it is different from what you see in the university. In the university, this is the famous way of writing it. Integral of u dv is equal to ub minus integral v du. Memorizing it is very simple. Yes, u dv is uv minus v du. The structure is more or less the same, but let us stick to that one, because if I want to teach it in this way, then you will be confused. Okay, but this is not hard actually. So you see that this is not very nice formula. Why? Because you want to calculate this integral, but you didn't succeed to solve it because you reduce this integral to another integral. Yeah, do you understand? The logic is not that simple. So instead of calculating this one, you reduce your problem to, this is of course good, this is no problem. In principle, what is f of x is just this integral of this part, which in principle you know how to do that. Yes, but you reduce the problem of calculating this integral to calculating another integral with the hope that this new integral is simpler than the first one. If this is the case, then you can solve the problem. This, let me tell you, this formula is 100% true every time, but it is not 100% useful every time. You understand that? It becomes useful only if this new integral is simpler than our integral. If that is the case, this is useful. Otherwise, it is useless, even though it is true. Is that understandable? But let us see how this will work. How this will work for this one. This is also a little bit of so it is a little bit strange. If I want to, yes. Yeah. So here, let me use my experience to call this one g of x. You might say why. Yeah, I will tell you why if you want to do it. What happens the other way around? Let me call it f of x. Yes. You might say that why I didn't call x f of x, and then you will see it will not work. I will tell you. But let us get rid of solving this one first, and then I will come back and tell you why it does not work. Okay, so if I want to go to the right-hand side, so this one that I want to calculate is exactly this. If I take this one f and take this one g, and now what I need, what ingredients I need on the right-hand side? I need capital F, but capital F is easy. Yes, capital F is just a primitive function for this part, e to the power of x. So can you tell me what is f of x now? Capital F of x is e to power fx itself. Agree? What more I need? I need g prime. So what is g prime? What is g prime? 1. It's 1. Yes? And now let us plug that into that formula. So this integral, let me call it I is equal to capital F, which is e to power x, multiplied by little g of x. Little g of x is just x, minus the integral of the capital F, which is e to the power of x, multiplied by g prime, which is 1, and then d of x. Now, this integral, do you think this integral is simpler than the original one? Yes, because the original one was x times e to power x. The new one is just simply e to power x. And can I calculate that? Yes. So what is this one? It becomes x e to the power of x. And then here it becomes minus e to the power of x again, but of course plus a constant. So we calculated that. Yeah, is that understandable? So it is complicated and you need to gain a lot of experience. You will learn more of this in the university. But it was not above the math knowledge that you have right now, so you understand what's going on. Okay, if you want, let me just check it in this scratch paper that what I have done is, what I have written is correct. So I go to scratch paper. What is your expectation? If I take the derivative of this combination, what do you expect to get if I have done everything right? What is your expectation? If I take the derivative of this one, what I am supposed to get if I have done everything right?
X times e to the power.
Yes, I need to get this one. Yes, because I am claiming that this is the primitive function for this. And so if this is right, so let us calculate. If I take the derivative of this combination, the first part is the product rule. So it becomes the derivative of x multiplied by e to power x plus x derivative of e to the power of x prime minus e to the power of x prime. And then this becomes 1 times e to power x, which is e to power x. And then this becomes x e to power x. And then this becomes minus e to power x. And you see that this is canceled. And then I get exactly what I guess. But now that you see the solution, you realize that it was not that hard to guess, yes? But this is not a systematic way. This is just an educated guess. But this is a systematic way of solving the problem, okay? But now, before moving forward, so let me finish everything now. Let me finish the solution. So let me finish this solution, yes. So here we have this, e to the power of x, y is equal to, then I have x e to power x minus e to power x plus a constant. But I am looking for y, so I divide by this. This becomes x, this becomes minus 1, this becomes c e to power minus x. So that is the general solution for that differential equation. Yes? Am I right? It seems a little, let me double check that. Let me take the derivative of this. The derivative of this is 1 minus c to power minus x. And let me add it to this one. If I add this one to that one, yes, you see this one will cancel that one. This one will cancel this one, and x is left. So that's correct. Yeah, that's correct. Okay, so now let me go back. Do you remember I told you that the other way around will not work? Let us understand why, because if you understand, you can solve the problems yourself. So for example, assume that I want to still calculate I, x e to power x dx. Let us see what happens. Let us take this one to be f, which is, it seems more natural to take the first one to be f, the second one to be g, and let us understand what's going wrong. So if I take it in this way and I ask you what is capital F of x, it becomes a primitive function for this one, which is x squared divided by 2. Yes? And then what is g prime of x this time? G prime of x is e to the power of x. Okay? According to the formula that you see here, capital F multiplied by g of x, which is 1 over 2x squared e to power x minus the integral of capital F, which is this expression, and then g prime of x, which is this one, d of x. So I is equal to that. Is this wrong? No. It is 100% correct. But is it useful? No, it's useless. Because my original integral is simpler than the integral that I have now, yes? My integral was x times e to power x. Now I have made the problem harder for myself. X squared divided by 2 is multiplied. It's clear that this integral is harder than this integral. But is this equality true? Yes, the equality is true, but useless, yes? So this is important. If you want, this is not guaranteed that whenever you have a product, this method will work, but this is one of those methods that might come to your mind if you want to solve it, and experience is needed. Sometimes one choice is good, the other choice is wrong. So you need to sometimes do some trial and error, or you have enough experience to calculate. Yes? Is that understandable? Let us concentrate a little bit on mastering this technique a little bit here. And then we continue the topic of differential equations again on Thursday. Okay? I will try to come up with a conclusion, but I don't know, Monday is also available on week 23, yes? Yeah, let us see how it goes, but that is, I think, good. Okay, so here, let me give you some exercises we can solve together. So that formula, I will keep it here on the board. And then let me ask you how, for example, so that's a deviation from the topic of the differential equations, yes? So we want to calculate integral of x times sine x dx. So how should I think about this? Whenever you want to calculate a primitive function of a product, one of the methods that might be useful is the method of integration by parts, not 100% all the time. Okay, but let us assume that this is one of the methods that you want to try for this integral. Okay, there are two choices, for example, yes? One choice is to take the first one x to f, the second one g, or the other way around. Which one is useful by having that experience now?
The first one to be g.
To be g is better, yes, here. Again, exactly the same scenario is going on. So here, let me take this one to be g of x, and let me take this one to be f of x. Okay, immediately I need to calculate capital F. So capital F is easy. A primitive function for sine x, if you remember math 4 lessons, it's just minus cosine x. And then the second one, you need to take the derivative. You see, don't get confused. One, you find primitive. The other one, you find derivative. So derivative is simply 1. Yes? And then what you do, you need to remember the formula. So the formula tells you capital F, which is this one, multiplied by little g, which is this one. So it becomes minus x cosine x. And then minus integral, capital F is minus cosine x times g prime of x dx. Yes? But hopefully you agree with me, we can immediately calculate this new integral. Minus goes out, 1 is nothing, so it becomes positive integral of cosine x dx. And then if I continue, it becomes minus x cosine x. And then this one becomes positive sine x. And then we usually put this constant of integration. So this is your primitive function. Of course, it is not bad if you go to scratch paper and work this out. Differentiate this function. You will see that everything will be simplified. This will be left. Okay, is that understandable? Let me give you two more examples. There are many examples, but if you want, we can solve some more fun problems here as well. But let me just finalize this session by solving two more examples. So what happens if I want to calculate this? X times ln of x dx. Okay. So what do you think is useful here? Which one to take F? If it is going to be solved by this method. First of all, how should I think this method might be useful? Because that's the product of two functions, yes? Okay, so which one is useful here? Which one to take F, which one to take G? Yes?
X is G.
X is G. If I take xg, then I have to take f ln of x. This would be problematic. Why? Can you say why? Because what I need is capital F. If I ask you, do you know a primitive function of ln of x? No. So this is useless, yes? So let us not do that. Okay, let us check. Let us do it the other way around. So yeah, it might be a little bit different from the logic here. The reason that I switched here to taking this one to be F, this one to be G, because if I do it the other way around, I will get stuck even in the first step. Yes, I cannot continue. But if I take it in that way, now if I ask you what is capital F, can you tell me? At least we can tell what is capital F here. What is that?
X squared.
X squared divided by 2. But I don't, if I ask you, do you know capital G? No, we don't know. But do you know G prime? Yes, we know. Yes? So G prime of X is, what is that? Remember? 1 over X. Okay, let us write this integral I, and then let me calculate. I is equal to, according to the formula, it is the capital F multiplied by little g. So it is 1 over 2x squared times ln of x. Minus capital F, which is 1 over 2x squared, multiplied by g prime. G prime is 1 over x dx. Yeah, so we are successful now. Why? Because this x and that x are gone, and this is really simple, yes? So let me just simplify and then continue. So this becomes this expression, and then 1 over 2 goes out. One of these x, this x and one of these x's are gone. So what is left for me is just a very simple primitive function, yes? Okay, so I just copy and paste the first part. And then it becomes what? 1 over 4x squared. Then I put a constant there. So it might be you were not able to guess that. So is that understandable now? So if I do it the other way around, it's a true statement but a useless one. But this is useful now. Yes? Okay, we can also let me immediately confirm that we have done it right. And then we can solve one more problem and then we are finished. So I need to differentiate this. Let us do it immediately. This is the product rule. So the derivative of the first one is 2x, which will cancel this one. It becomes x ln of x plus the derivative of ln of x is 1 over x, which will multiply here. One of these x's are cancelled, so it becomes 1 over 2x. So this part is just the derivative of this part. What is the derivative of this part? Is minus 1 over 2x. Do you see? This one and that one are gone, and x ln of x is left. So what we have done is completely correct. But let me give you another example. So what is your idea about this? Do you remember I told you that the reason that we couldn't take it the other way around, as Jessica said, is because we didn't know how to find a primitive function for this. But let us try that now. This is the first time might be you see that. What is the integral of just ln of x dx? So it seems that this formula is useless. It is not a product, it's just one function, but that can be viewed as a product, yes? How can I see ln of x as a product? It's very trivial, you don't need to think at all. ln of x is ln of x times 1, yes? So you can write it in this way, L1 times ln of x dx. Yes, even though it was not as a product, but nobody complains if I write it like that. Then I will give again the role of g of x to this one, because still I don't know what is the primitive function. I give the role of f of x to this one. Yes? Okay, now what can I do? What can I do? I can write capital F. So what is capital F? Capital F is a primitive function for that which is x. Do I know g prime of x? Yes, of course we know it's 1 over x. So this integral that I am looking for is equal to capital F, which is x, multiplied by little g, which is ln of x, minus the integral of capital F multiplied by g prime of x. I'm just following the formula. And then this becomes x ln of x minus this one and that one are cancelled, so it is 1 dx. But if I ask you what's the primitive function for 1, it's famous, yes? It's just x and then plus c. So that's nice, yes? Now we know what is a primitive function for ln of x. A primitive function for ln of x is this combination, x times ln of x minus x. I recommend you, now that you know this, use the method, switch them and solve this problem again. This will teach you a lot, yes? But you need to use the result of that one. So if I wanted to take this one to be g, this one to be f, I need to solve this problem first, use this one there. By the way, it might be hard. Let me see if it works or not. So if I take this one the other way around, if I take this one to be g and this one to be f, then capital F is this expression, but it is hard. No, it's useless again, because this capital F will go there. And then I have to calculate that one, which is actually, yeah, it might work. I will teach you next time. There's a very nice trick how we can use this result to calculate that. So I will start on Thursday about it. Okay, but I think this is a very useful trick. It was better to know about this before leaving the high school. Okay, no questions? We come back again, continue the differential equations later. Thank you very much. I will end this stream now.